Today's lesson is 11.7, areas and volumes of similar figures. Problem 1. Are the two cylinders similar? If so, what is the scale factor of the first figure to the second figure? So if we look at our picture, I see a radius of 6, a radius of 5, a height of 12, and a height of 10. So if I compare those numbers, 6 to 5 and 12 to 10. This proportion should be equal. So if I cross multiply, 6 times 10 is 60, 5 times 12 is also 60, so these would be similar figures. 6 divided by 5 is the number 1.2. So if I took 5 times 1.2, that would give me 6. If I took 10 times 1.2, that would give me 12. So our scale factor is either 6/5 or 1.2, or you could talk the reciprocal. Here's our rule for today. If the scale factor of two similar solids is a to b, then their corresponding areas are a squared to b squared. And the ratio of their volumes would be a cubed to b cubed. So that's the main idea for today. A squared to b squared for area, a cubed to b cubed for volume. Looking at the next slide, it says, decide whether the two solids are similar. If so, compare the volumes of the solids. So looking at our first picture, the red 5 compares to the red 3, blue 5 to the blue 3, and the orange 8 to the orange 6. So if I look at that as a proportion, all of those fractions need to be equal. So I could figure out what they are as decimals and see if they're equivalent, or I could check by cross multiplying. So we know the first two are equal. So then if I look at the other two, I get 5 times 6 is 30, 8 times 3 is 24, so those would not be solids that are similar. Part B. Again, do the same thing with your ratios. 10 matches to 5, 6 corresponds to 3, 14 corresponds to 7. So right away I noticed this relationship of 2. They all reduce to 2. So because of that, they are all similar. And 2 is our scale factor. If we look at what we did on the last slide, scale factor is a to b, area is a squared to b squared, volume is a cubed to b cubed. So we're saying that our scale factor is 2 to 1. So if we had the area of the face, which is 60 of this base, the area of this bottom is 15. So if I multiply 15 times some number, that should give me 60. And if we wanted to figure out what that number is, this is our scale factor. To talk areas, we'd have to square that, so our ratio would be 4 to 1. So 15 times 4 would give us 60. Then to multiply volumes, if we had the volume of this object, which would be 15 times 7 for 105, our ratio of our volume would be 2 cubed, which is 8 to 1. So I could multiply that 105 times 8, and that would give us the volume of the larger object, which would be 840. So those are the relationships that we need to know today. Let's try this slide. Decide whether the solids are similar. So again, we need to look at the scale factors. So these are the relationships that I see, 3 to 5 and 4 to 10. So we double check to see that those fractions are equivalent. And we find out, no, they're not. 3/5 is not the same thing as 4/10. Same thing in number 2. In the second picture, the 5 is the radius, so we either need to double this to compare diameter to diameter or take half of 5 in the first picture to compare radius to radius. So I looked at diameters. So the first diameter is 5, the second diameter would be 10, the first height is 7.5, second height is 15. And it looks like those relationships reduce to 1/2, so this would be a yes. And that is our scale factor, 1 to 2. Cylinders A and B are similar with a scale factor of 2 to 5. Find the surface area and the volume of cylinder B given that the surface area of cylinder A is 96 pi square feet and the volume of cylinder A is 128 pi cubic feet. So here's my setup. I start out with this relationship of 2 to 5. If I want to talk surface area, then I need to square it. If I want to talk volume, then I need to cube it. So those numbers make 4 25ths and 8 125ths. So our ratio is 2 to 5. A is obviously smaller than B, so we have to get larger. So we would probably want to look at the reciprocals of the numbers that we wrote. So to calculate surface area, we're going to take the 96 and we have to multiply it to make it bigger. So we're going to multiply by the fraction 25/4. And we get 600. So I did 96 times 25/4, and then I'm going to leave the pi on there. For our volume, we're going to do the same thing, except we're going to multiply by the volume ratio. So that would be 125 over 8. And that gives us 2,000 pi. And those are the two answers, 600 pi for surface area and 2,000 pi for volume that we were looking for. Let's try another example. The two cones are similar. Find their scale factors. So we can compare the volumes. 108 pi divided by 256 pi. And then notice my pi's reduce right away, cancel off. And we are comparing volumes. So this is the comparison that we're looking at. So I'm going to set it equal to a cubed over b cubed. So I need to get a to b to find the scale factor. So I need to get rid of the cube. What will get rid of a cube? Cube root. So to get this on a calculator, I'm going to hit math number 4 and then type in the number. And we get some decimals. So I know something's not right. So I look back at my fraction, I notice that both of those numbers are even, so I can reduce that fraction. And that fraction reduces to 27 over 64, as seen on my calculator. So now what I want to do is take the cube root of 27 and the cube root of 64. Try this on your calculator. And now I get 3/4. Let's try another one. Two punch bowls are similar with a scale factor of 2 to 3. The amount of concentrate to be added is proportionate to the volume. How much concentrate does a smaller bowl require if a larger bowl requires 48 ounces? So we are comparing volumes. So we need to cube our 2 to 3. So that gives me 8 to 27. That is the ratio of the volumes. 8 would be the ratio for the smaller bowl, 27 for the larger, so the 48 is the larger. So I'm going to set that in my denominator. And I need to find the area of the larger, or the smaller, excuse me. So to get rid of the 48, we're going to multiply, because that's the opposite of divide by 48. And I get about 14.2 ounces. On the next slide, we're going to find the scale factor. What is the scale factor of two similar prisms with surface areas of 144 and 324 square meters? Complete the table to help you figure it out. So the ratio of the surface areas are 144 and 324. And that ratio stands for a squared to b squared because we're talking surface area. So to get a to b, we're going to take the square root of that. The square root of 144 is 12. And the square root of 324 is 18. So 12 to 18 can be reduced to 2/3. Let's try another one. The volume of two similar solids are 128 cubic meters and 250 cubic meters. The surface area of the larger is 250. What is the surface area of the smaller? So these questions try to lead us to the right answer. Number 21. Let A to B represent the scale factor of the similar solids. Circle the simplified ratio of the volume of the smaller solid to the volume of the larger solid. So it looks like we're picking from the first one and the third one because those are cubed. So we want smaller to larger. So we'll choose the first one. So that means we're going to put the 64 in here and the 125 in here. And the cube root of 64 is 4. The cube root of 125 is 5. So that is our A to B. But we want to talk surface area. So now we're going to use our A to B to get the ratio of the surface area. So 4 squared is 16. 5 squared is 25. Number 24, circle the proportion that compares the surface area of the smaller solid to the surface area of the larger solid. We were told that 250 stands for the larger solid. So again, we're doing surface area, so we're working with this one. And now we need to take that proportion and solve it. So to get x by itself, we'd have to multiply by 250. And we may as well plug in our 16 over 25. So I'm going to multiply both sides by 250. And I get x equals 160. Try the next problem on your own. Please pause the video while the students work. Here are the answers. This concludes my video.